Hey, I think we're back. Are we back? We're back. Bad people. Woo! Woo! It's lovely to see everybody back. Lovely to see everyone returning from lunch. Those who've stuck around and those who've left. Well, honestly, they were holding us back. So, all right. So, right before we left, we were talking about how can I achieve my two goals of user interface engineering. One, displaying content. With HTML, it was so intuitive. We listed out the things we wanted in our C++ list of elements that would show up on the page automatically by design through our layout and render engine, all part of Web Core. And we loved our HTML, but unfortunately, in practice, it gave us no data associated with what we saw, meaning the user couldn't actually change what they see. Because even though I feel like I'm seeing data when I see the number 7 displayed, could be by HTML, I can't actually change a collection of pixels, maybe 30 pixels that look like number 7 into number 8 unless there's associated data underneath it. Because even though I think when I see it change on the pixels that is a change happening, that is not the change happening. The change must be happening in a data store, in the computer's memory, in the computer's store of information somewhere in the machine. And we only have changeable or mutable, posh word for changeable, data available to us and the ability to write code to do that in what language, everybody together?
JavaScript.
Exactly, well done. Not like the last time I did that and somebody went HTML, which was, no, JavaScript, perfect. There's nothing like having an open-ended question as you've been on a stream of flow and people tune. Anyway. All right, so we were able to display data on the page via our C++ list of elements. Beautiful. Now, can we let the user change the content, the data they're seeing, which implies changing it in JavaScript and changing what they see on the page? Well, we know we can display content from JavaScript into C++, into the DOM, into the list of elements. Can we go in the other direction? I mean, obviously, we will be able to. It'd be a great shame if we couldn't, but let's go. We've lost our schematic here. Maybe we'll keep our schematic up here in general, just because it lets us sort of keep track. But it's a good reminder here. So we have our, what are we calling it? App.html. Schematic, people, is just a posh word. I mean, I think it's what it means. I didn't really check. I heard that word used. It's a word that means like the structure and how those things interact with each other. I think that's what a schematic is. I don't really know. I suppose it is. Sounds right, doesn't it?
If you say so.
Who knows? Probably true. There we go. And that loads into the HTML parser that is going to look through each line of it and add each piece to the C++ object or list of elements, but technically an object, the model of the page, the DOM, that's all loaded into there, from which we will produce the actual pixels of the web page through the layout and render engine. Nice. As soon as we hit in the HTML parser and add it to the DOM, the list of elements, a script for JavaScript, that will tee up our JavaScript engine to run. Our JavaScript engine has a store of data, yay, that can be changed, and a place to run code, a thread of execution, that can change that data. Beautiful. And that will also give us access to a pre-inserted object by the name of document that has a ton of links to, has a reference, to this C++ object, the DOM, that we can then use to run functions and add elements on here or search for existing elements. Okay, and that's what we're going to do right now. But before we do that, we're going to start off by loading in HTML. So over here is our web page, I guess, the actual pixels of it. There it is. We know that anything on it directly mirrors our C++ store of, or list of elements that when an element is added to that list, and technically it's an object, O stands for object, but just for our purposes, we'll think of it as a list because an object and a list, they're both stores. We just imagine a list with imagine an object with each sub-object having a key 0, 1, 2, 3, 4, 5, and that's your list. In fact, JavaScript lists are implemented as objects under the hood. So, but we'll think of it as a list. It's easier for us to visualize. Every element added here is automatically added to the page through the layout and render engine, meaning all we have to do, at least with HTML, was list out our elements, not worry about pixels, any of that stuff. Beautiful. Now, unfortunately, it is in C++ runtime, and we are not able to directly write code to interact with it. Instead, we have a double line to represent our division between this world that is in C++ and our JavaScript land. We start off with, I'm going to load it from here. Well, we start off with that I'll just write it here. We start off with that HTML file loading. The first line, let's go through and add our elements to our C++ list. Let's have Justice. What elements, what nodes are we adding to our C++ list?
Got an input.
Input, exactly. I'm just going to list them like this. Yeah, input.
And a div.
Perfect. Oh, I didn't help myself by putting that. I know how we're going to run out of space. So, okay. We have an input. Exactly. We'll put it here. Input. We have a div. And then finally?
Script.
Script. Perfect.
Our JavaScript.
Which links to our JavaScript, which is going to spin up our JavaScript code starting to run. Because that's the perfectly designed way of having your main runtime start executing. And that's where we're going to go now. So HTML code is executed. I'm probably going to actually, that is erased because it was a one-time running of that file. Run through it line by line and done. Now we move to our full runtime, at least the one that we can access, JavaScript. It can save data. It can run code to change that data. It can even arbitrarily, which means, I don't really know what it means, like at a late, not in order down the page, at a given moment, can run more code. Wouldn't it be great if that time it's running code is in response to maybe a user doing something over here? Oh, what have I forgotten? I forget it every time. Please, somebody call me out for it. Every time. What have I forgotten, Phil? Alexa, what have I forgotten?
Once your elements are on the DOM, then they also appear on the page.
Yeah, I keep forgetting that every single time. There it is. There's our input field, and then here's our div. And then I think Phil was about to help us with the JavaScript runtime. We have in JavaScript, we have a call stack that is going to keep track of all the functions being run currently. We have, initially, we're in what's called the global execution context, which is the main file of code and all the code we're executing, running there. Beautiful. It has immediately loaded into it. When JavaScript engine app, it's just an app, code running, is running in the web browser, it automatically gets an object preloaded into it as soon as it starts running by the name of what? Well, quite a few. So it's kind of, which one are we using to get access to this C++ DOM? Justice?
Document.
Document. Spot on. Exactly. Well done to Justice. There it is. Document. Oh, holding this right well. Yeah, document. And that is a big old object full to the brim of functions and properties that are actually getter-setter properties that allow us to search, add, interact with, from JavaScript, this C++ list. That we know anything on there will show up on the page. Okay, it doesn't sound quite so bad. Unfortunately, we know that that process can get pretty convoluted, especially when we compare it to HTML. It's like, if we didn't know about HTML, maybe we think it's okay. When we've seen HTML allows us to describe exactly what we want on the page in order down the text file, and it show up in full on the page via the list. And just, you don't even have to write push. You know how you add another element from HTML to the C++? If you want to add an element to a list or to an object, maybe you have to you have to sort of instantiate an object or class, or you have to push an element to a list. If I want to add from HTML to this list here, what do I do? Alexa, what do I do to add to this list from HTML in my initial writing of HTML? I'm not rerunning HTML.
You just write it in the HTML file.
On the next line. Or, yeah, exactly, yeah. Isn't extraordinary. I wish all my code allowed me to add to lists by just writing a line below and it being added to the list. Beautiful. Unfortunately, we don't get that here. So what we do get, though, is this object by the name of document that has a hidden link to that DOM, to that C++ list. I forget, I don't need on the blackboard to wipe out the, it actually works very nicely. Okay, and then I get a whole bunch of methods like query selector. There's others that allow me to create elements on here, all of which are not only taking action in JavaScript, they're also having action consequences outside, yeah, I'll do this in blue, outside of JavaScript. Okay, beautiful. So I think that is enough to get started with. So with that in mind, let's have a look at this code. We are going to save some data, an empty string post. We are going to get what I would call accessor objects in JavaScript for both our input element on the DOM and our div element. So we're going to get links from JavaScript to these respective objects in our list of objects that is in C++. It's portaling, it's portholing out the back, it's out of the back of JavaScript into this position in C++. Referencing, pointing to. There you go, all those work. We're then saving a function, handle input. We're then, this looks interesting. We're going to use on the linked object.js input to the input element on the DOM a property on it that does exist already. We're not assigning. This is a property on input that is going to turn out here to be a setter property because on the left-hand side, the right-hand side is the thing we're going to grab and set, in this case, as the handler of any action that comes from the user that leads to some change in what the user, in change in the DOM. This is going to handle some action from the user. And this, of all the names in programming, handler is not the worst name I've seen. Like a lot of them are pretty terrible. This one handles what the user does. Exactly. This one handles what the user does. Fantastic. It's going to be triggered to run back in JavaScript at the behest of the user's action. That's a good phrase, isn't it? All right, and then we're done, but let's see. Okay, let's get started. I'm going to go person by person. Paul, oh gosh, here we go, Paul. You're up for the challenge. Here we go, Paul. Line 1 in our JavaScript code. We've already filled in our document object. It's there. It's going to give us access to this C++ DOM. Line 1, we are trying to build out, remind ourselves people here, a full user interface. The ability to display content for the user and for the user to change that content. Should be trivial. Turns out in the web browser, flipping heck. It's 4 different APIs, it's 5 different runtimes. No, not 5, we'll see. Paul, go ahead. What's our piece of data that hopefully we're going to end up displaying?
We're defining a variable.
Yep, perfect.
And it is an empty string.
Yeah, and what's the value? What's the identifier of the variable? What's its label? Post, perfect. Posh word for label, people, if you want, is identifier. There it is. Post is an empty string. Next line, left-hand side, Paul.
We are, again, creating a variable called JS input.
Perfect. I tend to call these a const. Variable being, I guess, a generic name for a label, but it's a label here where what's assigned to it will be, constantly assigned. We will not be changing what's assigned there. I mean, we can change out its values if it's an object, but we will be linked to this object permanently. So a const, JS input, and wow. Okay, right-hand side here. Can you talk me through what happens, Paul, on the right-hand side here?
I'm not going to do as well as it was done before.
Do not worry.
Okay, so it's going out to the document. It's running the query selector function.
Right, so, yeah, go ahead, keep going.
Which is going to look into the CSS DOM.
So into the C++
C++,
DOM. Yep.
Sorry, C++
Don't worry.
DOM. For an element of type input.
Beautiful. Does it find it?
Yes.
It does. Can it bring that whole C++ object back?
No.
No. So instead, query select. So let's write it out here. So we get one. We're going to look at the link to in document, which is a link to the entire list of elements. So link to the entire list of elements, the DOM. 2, we're going to query, we're going to search for a given selector, label by which we can select something, which is input. And 3, because we can't, and we find it. And 3, because we cannot pull that object back in. And by the way, it looks something like type input, because we can't pull that object back in, instead, in JavaScript, we're going to produce, I guess, a corresponding object. It's not the worst way to refer to it. And it's going to have, actually, let's just store it into JS input rather than do it here again. It's going to have a link. I'm going to keep it smaller this time. A corresponding object with a link to the underlying input element and functions that are going to allow us to edit that input element. We then, you can almost think of this as its own execution context. We then, out of that, get that object and assign it to the global const. Paul, what's our global constant it's assigned to?
JS input.
JS input, spot on, fantastic. And it has a hidden link to that input. There it is. Beautiful. Looking nice. Now, yeah, that's looking really nice. Excellent. And that has on it automatically a bunch of useful methods. There's a lot. Which ones, Phil, can we see here that we're actually going to use in this particular code?
On input.
On input. Is there another one there as well?
Let's see.
I call them methods. I guess they're really properties, sorry.
Text content.
Text content, that's going to be on our next one. Can you see on line 5 there what's...
dot value.
Value, perfect. So we have value, and these are both going to give us, when run, access to go and set or get from a C++ object. That's also, I gotta say, I give credit to JavaScript for giving me this fine-grained control. Let's do another one without me going out of shot. So, well done, Paul. Ian's already done an amazing job. So, John, you're up. Left-hand side of our declaration there, our assignment there, sorry, is declaring what constant?
JS div.
JS div. And what are we going to assign it, John?
Then we are calling document query select.
Yes.
Documents query selector method.
Yes.
Passing the div argument.
Well put. Yes, perfect.
And then that first goes to its link DOM.
Perfect. Yes.
And then finds the div.
Does it find it?
Yeah.
You bet it does. And it's querying for div. It does find it. We can't pull that C++ object back in.
Yeah, so it is creating a JavaScript object
Beautiful.
that represents it.
That represents it, exactly. And it's specifically got a hidden link to it and a bunch of useful functions to edit it. Perfect. And then that gets assigned to what global const? John?
That gets JS div.
JS div, sweet, excellent from John. Exactly right. And there it is, our object, and it's got a link hidden to, by the way, technically the way that link is specified in the JavaScript spec, which is the rules of JavaScript, it will say host defined. The host is where is JavaScript running, which in this case is the web browser. And so host defined means do not JavaScript expect us to, do not anyone else expect us, JavaScript, to define where in memory that will be. Have the host, which is the browser, give us just a position in memory, and that's all we're going to have. So that's what happens. We have a position in memory, which is the div element. There it is. Beautiful. Perfect. And then we also get added to this JS div as specified by the DOM API, written up by WebIDL. See, just, I mean, some of these things, it's more just like, it's nice. The model's more important than the names, but it is nice to have those names because we do want to be able to go and use them and annoy engineers by saying things that they... No, we want to be inclusive of the other... We want to make sure that all the people interviewing you are feeling comfortable, but a little bit intimidated, so that they... Who wouldn't want to have your interviewer a little bit intimidated in a good way, in a polite way? There it is. Text content, oh, I guess I shouldn't suggest it's a function, but it is acting like a function. It's a property, but it's, yeah. Okay, perfect. We now have two, we heard representations of DOM elements in C++. I would call them corresponding objects. I would call them accessor objects. Okay, all of them are just made up terms, by the way. Don't expect to like find those in. Okay, now Y. What are we doing in our next line? What are we defining here?
Line 4.
Yes. Yes, perfect.
So we're using the function keyword to say, hey, runtime, assign in memory, make some space for something called handle input.
Perfect. And assign all of its code.
And it's, yeah, it's an
Function
object
definition. Yeah,
that can
technically an object
run
under the hood, but
arbitrary code.
all right, this is the fanciest definition of a function ever. So well on Y, we're defining a function handle input. We've got a really good description of how it's doing it in memory. That's really cool.
Sorry.
No, it's really good. It's important. It's saying store up, free up some space in memory to save the text of this function. Absolutely. And or a parameter list, a list of potential inputs. Well, there's none. So yeah, but there would if there were. Yeah, perfect. Now, because the reason I say it's so valuable is the next line is a tricky line. The next line is a tricky line. So let me give a verbalization first. Or let's say the goal. Our goal is we've written a function handle input. We do not go inside it right now. We just grabbed all of its code. Remember that, people? No going inside of function definitions until they're executed, invoked, called. We just grab all of its code. We've saved it into JavaScript memory. What we wanted to do, taking a look at it, it's going to update JavaScript data post with the value, potentially, I have a feeling, from running the value getter, in this case it's going to behave as a getter, to figure out whatever the user wrote here, and there's appeared on the DOM element that is linked to by JS input, so that input DOM element. We're going to grab that, pull it back into JavaScript, and we're then going to use that, line 6, to update JS div text content. Oh, that wasn't good verbalization, right? To use the setter method property on JS div to update the div's text in C++ on the DOM. We don't know when the user is going to start writing something in the input field. And this is where we want to, instead of trying to execute handle input right now, save it, ideally, I guess a link to it from the input element on the DOM that can then enable it to be passed back, called back into JavaScript. If you've watched hard parts, callbacks, and harder functions, I always thought it was weird they were called callbacks because they were never called back. They were executed right there and then inside a map. When you pass a function to map to execute, it's executing right there and then inside the hard function. A callback to me is something where it's like we've saved it, a reference to it, and at a given moment, maybe when a user starts writing, it's called back into JavaScript to be called in JavaScript. And that is what we hope will happen here. Our goal is that this function's code that Y so perfectly described being saved will be somehow set's not a bad word for it here, set to this input DOM element's handler to handle the user inputting on this DOM element. Remember, these two are completely bound together. Any code written here, if the user types anything, the DOM element will know. And to have that set as its handler that will then run JavaScript code back here, will call that function definition back in to JavaScript, such that it can execute, such that it can run, that we could then go grab the data that's on the DOM at that point from the user typing, right? Two things are happening. The user's typing, it's triggering a function to call back into JavaScript, and it's putting data in the value property here. Pull that back into JavaScript. We can then go, pull that data back in, assign it to post, and then use that updated value of post to update our div. If only we could do it right there and then. You get it? Instead, we're going to put that data in there, into that input field. The user's going to type in the input field, and we're going to have to bounce back and forwards. But we have to, right, because there has to be data that can be changed. Remember, seeing 7 on the screen is pixels. It's got to be changed to 8. That means there's got to be underlying corresponding data. Fine, the DOM has that. Not enough. That we can change. Only JavaScript has that. Meaning any change we want to have happen, which is vital for the user to experience anything, otherwise there's no change, it has to happen in JavaScript. Okay, so let's do that. Great job. Let's assign that function in line 8. Give it a go, Alexa, if you don't mind.
Okay, so we are going to find our JS input object. in our JavaScript
Yep.
memory.
Keep going.
And we are going to set, well, we're going to find our JS input object and use our link to that DOM element.
Perfect. We find our JS input object. Look at that. Perfect timing. Find our JS input object. There it is with its link to the corresponding DOM element input. And
then use on input as a setter to set the handler
Exactly.
for input.
exactly, set the handler for handling input. Exactly.
To be our handle input function definition. in
Yeah,
JavaScript.
beautiful. And technically, it'll be a reference, because just like we can't pull a C++ object into JavaScript, vice versa, we can't attach a JavaScript function in C++. Instead, it's a link to this function back here. But for our purposes, just visually, we'll show it right there. Beautiful. Fantastic. So we used our setter. I want to hear clarifications on this, people. Please don't assume that others are getting this. I want to have someone verbalize this for me in a second. This is a really hard line. So JS input is the link to our object in JavaScript that we created earlier by querying for the input element on the DOM. We got an auto-created object with a hidden link to that DOM element. We're now using that fact to run its onInput setter method. This onInput setter property, was added automatically with the help of query selector because it knew we'd got a link to an input element. So it adds all the appropriate functions. It's really, it's good. It's good, I'll give it that. We're going to use that setter to, well, one, we're going to check what the linked element is, its input. So check that it's, and then we're going to two, set the handler for handling users' input. As far as the bad names in programming go, and there's a lot of them, handling input being called a handler, handling the user's input, that's got to be one of the best names. Like, I would call it that. And that suggests like I think I come up with great names. I don't, but I would. Exactly. Okay, and we're going to set its handler to be the handle input function code. Beautiful. And that's it. We now have a full, I'd actually argue we now have a full user interface. We've set it all up, right? We have content, we have displayed, I guess, structure, boxes for stuff to be, we have a place for a user to write something that they are then going to be able to trigger that affecting their underlying data, and that affecting of the underlying data in line 5, we're going to grab whatever the value is that they typed in and store it in post, will then be used to affect what they see by changing divs content on the page. We're almost there with a full end-to-end. I'm looking at the time. We're doing great for time just to get the most basic. But I promise you, we will, by the end of today, I was saying this to everybody, online people, I was saying this to everybody here earlier, we will be able to, by the end of today, by the end of tomorrow, have built out a full virtual DOM from scratch with diffing implemented, with state hooks implemented from scratch, functional components from scratch. We will have a full visual DOM. We will build out one-way data binding by the end of today. So if you're feeling, I've seen 5 lines of JavaScript here, know that this is the foundational pieces that will allow us to join these up and achieve all those hard parts to come. So I have to put that caveat there because one's watching the attendee count online just go like this as people get exhausted of no, that's a joke.
They're still there.
They're still there. All right, people. Okay.
Can I have a question?
Yeah, actually, Magic, this is a perfect time. Just before you go, Magic, just 1 second. We've now set up, time's going to pass, and what's funny about this now, and this is the nature of user interface, is this system is now going to get hit from outside of it, okay? And that is going to be the user writing something. So we don't have code for the user writing. So our execution of JavaScript is actually finished. JavaScript will continue to run because there are functions that have been set to listen. And it keeps track that there have been functions set to handle a user action. So it won't actually execute JavaScript. However, we are done with our synchronous code that we wrote. We're going to now have the user take action from outside of this system, and that's going to then affect the flow of user data into JavaScript and back out onto the screen. But Magic, please, yeah, go ahead before we do that.
I was just technicality. This on input pretty much. I mean, that's implementation on the JavaScript side only, or is it? I'm just saying that on input, it's handling events from the DOM, obviously.
Correct.
But is the implementation going both ways, or how is?
Let's see it play out. Let's see it play out, Magic. We're going to see it right now.
Okay.
Yeah, that's a really good question. Let's see it play. And one of those ones where the line between implementation in JavaScript and in C++, if ever there's one, well, I mean, maybe many flaws of hard parts. If there's any flaw of hard parts, it is giving a clear mental model that functions completely, as in it has completeness. It will not break per se. It says, however, that there could be moments where the exact point at which the, say, difference between the C++ direct implementation, the excuse is always this, and it's not a bad excuse, is it's going to be browser specific and actual implementation in the given moment. That sounds like a sort of, but it's also true, because literally it could be implemented differently. For example, now, setting values is now implemented in JavaScript initially by proxies, by a new feature in JavaScript called proxy. That's only the case in the last 3 or 4 years. And it's not the case in all browsers. And actually, it might be the case in all browsers. It's really hard to tell. So it's like, you know what I mean? So that is both an excuse, but also that is the nature of developing in the browser, A. B, that's an excuse. C is an excuse for, like, you cannot always have it right in every single point. But C, it's like, because the goal of our getting these mental models is about having a clear mental model which fully functions, not always necessarily going 5 layers down for the sake of understanding, unless it's serving debugging, implementation, and understand. So in terms of where that exactly crosses, the question becomes, would it matter as long as knowing that when you run on input, you are finding the C++ DOM element, assigning to a handler a reference to the JavaScript function, that when the user takes action will trigger this executing by adding to the callback queue, we'll see in a second, put on the call stack. Therefore, does it matter where the exact step moves from being directly working in C++ or first handling it a little bit in JavaScript? For example, JavaScript determines whether it's going to be a setter or a getter by whether it's on the right or left-hand side. If it's here, we're going to be setting. That's happening in JavaScript, but it's then running a function in C++ saying, please now set, running the setter version as opposed to the getter function in C++. So it's like knowing exactly where one starts and the other stops is only relevant if it affects one's ability to debug and...
It's just a contract for understanding that there's a contract
exactly.
that's supposed to...
I think that's a good way of thinking about it. Exactly. All right. So let's now have user action happen. I'm going to use green for my user actions, okay? So user action. Here it is. User action. And our user action is going to be, let's say this is, I don't know, 1 minute. Because this user has been really enjoying looking at the input. They've been musing over what they're going to type in to the input. And they are going to type in hi, yeah, exactly. Type hi. There it is.
Profound.
Type hi, exactly. I do want to come up with some good alternatives. If anyone has a nickname that is under 2 letters long, I'll be very grateful for it.
Why?
Why?
Ho, 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 hi ho.
Hi ho. Okay. Ho. Okay. Is that your nickname? No. Hi. Oh, hi. I see. Ho. Hi ho. Okay. It's a Snow White reference. Exactly. Perfect. All right. Okay. Good.
That's true.
Good.
Y is just the letter Y. So
I know. That's literally the perfect nickname. That's perfect name. Sorry. All right. So as soon as a user types this, people, as soon as they type, we've already said this. Our value property in JavaScript. Sorry, not in JavaScript. Let me get that completely right. Our value property in C++. There it is. Our value in C++, oh, shoot. Our value, not in C++, our value in C++ is going to get populated with hi. There it is. We knew that from before, and that's going to allow us to have data that can then change. Okay, but we can't run code there. Don't panic. The DOM API, particularly its event API, is going to trigger this function to be called back into JavaScript, where it will, where should we put it? Let's actually put it at the top here, couldn't we? Where it will sit in a queue of functions to be called on the call stack, called the callback queue. It's a queue of function definitions, callback queue. It's a queue of function definitions. I never put it there before, but that'll do. As soon as a function is in there, and if you've been to async hardparts, you've seen this, but as soon as a function's in there, well, let's put it in there. So at this moment, actually it's handled by the render engine, because it's directly related to what the user sees and where they're clicking. So when they start writing hi in this input field, it will trigger in what's called an event. This is one of those names I don't love. Event. I don't know. It's a user action packaged up as a command to tell this DOM element, please run your function that handles the user inputting something. And that, it's going to take this handle input function and call it back into JavaScript to sit in the callback queue where handle input sits. And we're not going to get bogged down in the implementation of this async hardparts, not bogged down, async hardparts does this in more detail, but something called, well, does knowledge questions, who knows? Who knows what's the feature that's checking looping very quickly to check, is there any JavaScript code still executing currently? Yeah, Ian?
Is that the event loop?
That's the event loop, exactly, spot on. But we know we're now at 1 minute. I don't care how long our code took to execute, it was not a minute. So there's definitely no code left on the call stack. The global code has finished running. The global code has finished running. The global code has finished running. There it is. The global code, no, it's not. The global code has finished running all its code. And so the callback queue is able to pass the handle input function to the call stack, where it is then, okay, people, it's a big moment coming up. It's a big moment. You all know what's coming up. It gets added to the call stack. Okay, start stretching, people, because it's about to be a moment, people. Oh, that's not one that works. Okay, here we go. I don't see any parentheses, so I'm not seeing any calling of a function. Don't panic. As soon as a function is passed from the callback queue to the call stack, JavaScript's going to put parens on the end of it. Okay, anyone feeling excited for what's about to happen? Yeah, exactly. Because, exactly, been waiting all day for this. You know, I love this podcast called Kermode and Mayo Film Reviews. I love it so much. And you can see in the reviews, it's like, some of the reviews are like 2-star. These guys have started to fall too much in love with their own like memes and things. Okay, that's what I have to say. That's what I have to say. Put it in the room, exactly. But it's we're about to execute a function. We didn't have to make it execute. JavaScript auto-executed for that. Auto adds the bloody what they're called, parentheses, to say run this function, to take our thread of execution inside of the function, and to create a brand new, everyone together, 3, 2, 1.
Execution context.
Well done, people. that actually sat. Okay, for those who have not done JavaScript before, when a function executes, when a function runs, when a function is called, and it's added to the call stack to be run, in JavaScript, it creates a new execution context, a place in which to run its code. And a little mini store of data like this one, but just for while we're inside of this function. Beautiful. And that's exactly where we go right now, and that's why we create a new execution context. Oh dear. Oh, okay. Password is, that's nothing. There you go. That's where we create a new execution context in which we are going to run the code of handle input. Did we write the parens, Justice, to execute this function? Did we put the parens on? JavaScript did. Exactly. When handle input, Justice just pointed at the screen. That would do. But that would do, right? It's JavaScript doing it. Exactly. All right. Good. Justice, you got away with it. And into it we go. Where we are going to. Look at this line here. Post is going to be the result. I almost like to say the evaluation of calling. Oh, that's what I was going to say. I almost like to say calling the value getter. Yeah, go on, Ian. Can I really say calling when it's not a function? No.
I'm just so curious if post is it going to be H? Or is it going to be H?
Oh, great. Yeah. Yes. Ian's immediately right. Input is going to trigger an event on every letter. I was going to add that caveat. Don't worry, Ian. But because it's boring enough with the word hi, let alone if it's just the letter like H. You know, it's just like so. Right. Or why? No, you know, Y could actually work. For the first time, it could actually work. Yeah, that's really cool. No, Ian's pointing out immediately there a real issue that, well, not, I mean, it's fine. Handle input would actually be triggered to run on every letter. And that's okay. That means every letter. What we could do if we wanted to have it only run on fully entering text that we want to have sort of submitted to be displayed in this little preview window here is maybe on text key press down on the enter key, which would be key, I think, ID number 13, something like that. I think it's 13. On key press down, if that is key number 13, then run a function to handle it. Just for one of the hard parts, one of the things about hard parts is one has to keep the code as tight as possible, meaning we're using just on input here. But you're absolutely right. To be really clear, Ian's saying, hold on, handle input would be triggered to run on, the event is on every input by the key. H, then I. Okay, so really we'd have H the first time here. It's good to clear that up immediately. Yeah, we would definitely have cleared that up. Probably. No, we definitely would have cleared that up. Spot on. Yeah, no, absolutely. Okay, easy to tweak or whatever, but just keep it very simple. And we'll keep using hi for now, just as I say, to keep it a bit more interesting. So, I'm actually glad you brought that up immediately, and it's quite nice to clear up immediately. So, post is now going to be assigned the result of calling the value getter property on the JS input object that has access to the underlying input element, where we find the value is the string hi. It's brought back as a DOM string. As a DOM string, hi. And it's then going to be converted into a JavaScript string, which is then stored into post. There it is. Hi. Okay. It's been a lot of work, but flippin' heck, I'm really proud that we managed to get the user acting on what they saw by typing. It was an empty box, essentially, by typing, and that data coming all the way across to JavaScript. When I look at this now, so when you know that, you look and you go, wow, what happened here? But actually, to be fair, oh shoot, yeah. But it is the same model again and again and again. So we'll get used to it. I've heard people describe this workshop as going from difficult to tedious. So what a review. But it's going to go from difficult to tedious because we're going to be so familiar with search DOM and or use document object to access full C++ list of elements to add to create an element or to search for an element. Get a link to that element via an object in JavaScript that can host that hidden link. Then use methods on that object in JavaScript to edit, update, transform, delete, remove, move around the element on the C++ object. It becomes such a familiar pattern. It is the model of the web browser and the interplay between JavaScript and the pixels via the DOM. Okay, great. And so our second line there, Phil, can I ask you for this one? Maybe if you don't mind trying to do the sort of style of communication there in terms of our DOM element and what text content is doing here on JS Div.
Yeah, so we're going to start off by accessing the JS Div object.
Perfect, there it is.
We are going to, again, it's tough, a little bit tough to communicate through, but I guess execute the text content setter.
Oh, I love that. I love that. Really nice. Exactly.
And setting it equal to the value of post.
Which is the string.
Hi.
Yeah, beautiful. Okay. And which is setting it on the, as the text on the
DOM C++
element, yeah.
element
Yeah.
of our div.
I'm trying to work out how to get these pens more easily start working again. There it is. Text is set to hi from JavaScript, and that immediately shows up on our screen. Look at that, people. Well done, everybody. Well done. I start my own applause for all of you. Look at that. User has typed, and what they've seen on the screen has changed. It only took, oh my goodness. It looks kind of beautiful though with the colors, it does look beautiful. But it's astonishing how much work it takes just to make a single change on what the user sees via JavaScript's underlying data, via an event and a function that handles that known as the handler, and that is then passed back to JavaScript to the callback queue where it's, well, called back, sorry, passed, called back, might as well call it by what it is, right? Called back to JavaScript into the callback queue, added to the call stack at that moment, parens are added by JavaScript's engine on our behalf, a brand new execution context is created to run that code where we then used our global, just to make it easy, accessor objects to these DOM elements to find input, grab what the user had typed in value, stick it in the post JavaScript data. We updated our underlying data in JavaScript, which is where we're able to use, change, run code on that data to determine where to display it back on the page, which we did via the text content setter on the JS Div accessor object for the div element on the DOM, where we then set its text content. The property actually on the DOM element might be something like text. Again, we can look it up, but the exact implementation of this, all we need to know is that the DOM API is designed such that we can use text content to access this C++ object's text, to which we attached hi. And that appeared on the page. Imagine if we could have just done it right here. Right? They're literally probably next to each other in memory. Not a chance. But also not the end of the world once we have the model, right? We have a function. I mean, it kind of makes sense. It's like, imagine, you know what they're trying to do with this handler function is it's like a little package of code that allows us to change the DOM. Little package of code. It just happens to have to run in JavaScript. But it's like a little package of code that would be encapsulated to run on these two elements. But do we think of it like that? I don't know, maybe. I think the problem with, not least because of that console trick, is that we have no idea that actually there is these two different worlds. One of which has data that determines what the user sees, but we cannot change right there and then. We have to pull back into JavaScript to change that data, to then redisplay it by adding it back to that store of data, almost sort of, not even store of data, I guess it is. It's a sort of object that has all the data the user's seeing directly. Unfortunately, if we want to change that data, we've got to put it back into JavaScript. Meaning if we weren't tracking that data in JavaScript, we wouldn't even really know what data's on the DOM. Because note, we do not have this data directly on these objects here in JavaScript. It may look like we do, because when we write jsdiv.textContent, it would go and get the value of the text of the div, but it ain't there. these are just accessor objects. I fall into the trap. When I think about that object being pulled out, and then we add elements, we add data to it, I'm like, is that being added to this object? We're using this object's getter setter property to go and append information to a C++ DOM element. What that's going to mean is that we're always going to be doing this back and forth. In fact, every change of data is going to require a back and forth, a flowing through. And in fact, there's going to be no permanent bonds built in between data here and data here. Every single change between these two worlds is going to require a manual running of a handler function to go and run code in JavaScript to change the data here, then a manual execution, which was a term that Phil used, of a setter property to go and set data here. There is no permanent bond. If post were to change here, the text here won't change. We'll have to rerun a setter function, setter property, to make the change. I mean, given, as Ian rightly said, this looks a lot like we are setting a value on a key on an object right here in JavaScript, or actually if we were to console log.js div on maybe a sort of HTML line of code. To actually in practice for this to be a setter into a different runtime that every time we change the assigned value here would have to be rerun to reset that value over here. That's why UI engineering in the web browser is so challenging. Nobody would design this from scratch. All right, so let's have thumbs. This is now our core model. Well, let's just summarize it here, I think. So when we go to, you will do thumbs based off this. So when we go to, users can change what they see. Or let's put it better, change the content. See content, which was actually here, I guess, an empty box, that's content in a sense, and then change the content, which is to say they change what they see, the high, and change underlying data for it, and then display it on the page. They're changing what they see based on their action. User interaction, typing, clicking, in this case it was typing right, is registered. Registered is a posh word for the DOM element knowing, and this is one of those moments where it's like, how is that implemented? Well, all we need to know as engineers for building out web applications is when the user takes action on that input field, the associated handler triggers running back on the callback queue. It's literally a reference to that function is added to the callback queue. That's the DOM's job, and then JavaScript will then execute that function. DOM element, they know they're in their tap, but how can this cause a change in data which is elsewhere in JavaScript? Because of the handler functions. It lets the user action or input, known as events, posh word for events, is sort of, yeah, the construct that ensure that when a user takes action, an associated function based on that type of action, in this case an input event, triggers the associated function to handle the input, pass back into JavaScript, where we can then change the data. That key line there shouldn't really be there, honestly. It's weird because we're talking about let it be passed back. I mean, it could go before, right? This line here is where we are assigning, where we're storing that handle input function ready to be triggered by user action. By saving the function definition, oh, here you go. By saving the function definition of the DOM element where the user action event happens, the function will be called back into JavaScript and executed automatically. So what? Okay, that's very optimistic. Well, user actions can then trigger running JavaScript code to save or change the underlying data post, in this case, in JavaScript, and then change what's displayed back in the DOM by taking that data and sticking it anywhere we want on that list of elements. No, we have to manually re-update the DOM with our data. There's no propagation. Every time the data changes here, we have to manually go and update what's seen on this, or what's added to this DOM, C++ DOM. But we have a full user interface. Goal 1, display content, data inside the computer. In this case, it's in JavaScript as the view for the user to see. It has to be from JavaScript because that's where there's mutable data. Goal 2, enable the user to interact by tapping or clicking with what they see, the view, what they view, and then change that content, which means in practice, changing underlying data in JavaScript, and then we went from post being an empty string to hi, and then displaying that back on the view. All right, people, that's our full user interface. Let's have thumbs. I want to see every clarification question. If I punt some of them, forgive me, but because some of them will show up later. You lost me. I have a clear mental model of I need clarification. It's what is wrong with all of you? Matchit, you literally looking around.
Oh no.
Matchit, you do not need to emulate. Okay, why? Has anyone got clarifications? Why? Good. No?
It's not a question. I'm not sure it's super topical, but having like spent a bunch of time in imperative DOM land in like the teens and being like, why is it like hundreds of milliseconds to change this one thing on this list? This is the first time I've understood like, oh, it's because there's tons of memory being allocated. In the
it's all sorts of interesting pieces happening in this process. And I think
Quite
it's just,
insightful.
I mean, don't think that the 1 minute is because of anything to do. The 1 minute here is just the user is really preparing what to write. All right. Justice, you look like you have a clarification?
It might be off topic. So if you, I can save it for later too.
No, please go ahead.
So when you have a form, you have multiple inputs, and you're typing in data.
Right.
Is that data is being saved in the DOM C++ node, and then at some point when you want to then submit the form, all of that data that is then passed into?
For sure. Now, this is where you can, again, it wasn't like the HTML creators were being completely naive. It was totally plausible that you have HTTP forms submissions in HTML, meaning that the DOM could actually get that information and submit it as a form. Submit it as a post, posting to the server without working with JavaScript. The problem is we can't move any of that data around. We can't display it anywhere else on the page. We can't edit it. We can't really do anything with it. But because the page, the app, the screen, the pixels is a direct mapping via the layout and render engine of what's on the DOM, well, you can be sure that if you've typed on here, it's in the element in the C++ implementation here. It's just not over here, which is the only place you can change it. But we do get a little bundle of code that can bring it over here. Well, and/or trigger JavaScript to do the work of going and retrieving it. We actually didn't bring it with us. There's a way to do that with an event object. We'll see much later on. But instead, it just said, when the user takes action, run this function. And now we're back in JavaScript land at an arbitrary time. Not very arbitrary, actually, at an entirely appropriate time when the user's taken action and inputted. And so we know that this function is going to run when the user inputs. And that allows us to then, in that handler function, do the smart stuff we want to do, like grab the data, save it in JavaScript. We could add an exclamation mark to it, post it back, display it back on the div. So it would be hi and hi exclamation mark. Coming to Ian's point, if we did that, it would go H exclamation mark in the preview, then I, HI exclamation mark in the preview. Yeah, Mark.
How does the callback queue relate to the task and micro task queues? Is it different, and how does it fit priority?
Okay. So callback queue is our task queue. Micro task queue is our priority VIP line, as I know some of our audience like to call it. Some of our community here like to call it. So they are queues that have different priorities. So if there were multiple items in the callback queue, if the user we had a handler for input, but then they were also to click, these would all start queuing up here, ready to be added to the call stack once the previous one has been removed. So actually, sorry, I should have said this callback. I should have said that this callback here, handle input, which was called back in, I should have said has now been removed when it was added to the call stack. So this is removed. But if there had been a function in the micro task queue, does anyone know what actions in JavaScript put a function in the micro task queue? Ian?
Is that something like asynchronous?
Yeah. These are all asynchronous. What's the specific? Oh, you're talking about asynchronous functions.
Yeah, like
specifically.
if you invoke an async function.
Oh, yeah, exactly. Specifically, an async await under the hood, which is implementing promises, at least was. That goes into the micro task queue, and they take precedence even over. So they were both waiting in the queue here. The micro task queue would take precedence over the callback queue for being added to the call stack. But that doesn't, we're not thinking about that right here. Yeah, please, Mark.
Is high copied from C++ to JavaScript, and just thinking that they might have different encodings?
Yeah, it's definitely not it's definitely not a reference. It's definitely actually transferred across, or you copied in the sense of however a value is copied, which is different to how a position in memory is referenced. Ian?
Yeah, I had a different question. Earlier you talked about when you were reading the value from the C++ DOM node that was in there, you referred to its inner text as like DOM string
DOM
versus
string.
JavaScript string. Is there a difference there? Is that like a real thing?
From what I read, and let me check on that one for after a break or something. What I read, for a JavaScript string, it looked like there was no meaningful difference. That's what but I will check whether there's any moments, any places where that becomes salient. Because I happened to read that like literally a day or two ago. I mentioned saying where JavaScript strings have little difference from a DOM string. But I'll confirm that.
Cool.
Yeah, good question, Ian. All right, so I guess we're going to see that model again and again. So if you are feeling, gosh, that's a lot, we are going to see it again and again. But we do now have the end of Hard Parts Part 1, the end of our truths. Before we move to our
moves.
It's not catchy, is it? It's not catchy. It's not the new backpack, I'll tell you that. All right. Now we can display content and let our users change that content. I really like that phrasing now I think about it because it's nice and ambiguous. Intentionally, because content is here and here. There's no such thing as content that is, well, I guess there is. Once the pixels are on there, it's content. But if you want to change it, it's going to need to have some underlying data to change to be able to change the content. So now we can display content. Well, that's things like post here. That's data. And let our users change it. I like that phrase. Like, I know I'm dwelling too much on this, but like I think that is kind of like the essence is change the content. Well, that I'm afraid implies both changing some underlying data and changing what the user sees. They are the same thing, and if they're not, we've got a problem. HTML and the DOM work together for a one-time display. Our remarkably intuitive HTML adds elements to the DOM exactly where we wrote them in the code. I sort of thought about that. If you're trying to design a programming language to display stuff, my dream would be able to write the thing that's going to show up, the text that's going to show up, and then I want something on the next line, the next bit down on the page. Oh, I'll write it on the next line of the file. Like, it doesn't get much better where we write them in the code, then the layout and render engine displays the content. Apps, though, unfortunately, let users interact, change what they see, or change the content. That's it. I prefer my phrasing change the content than change what they see. Because see implies there must be content, but I just like saying content because then it's like, oh, wow, no, it really is. Content is what you see, and I guess it's the underlying thing as well. It's, overly specific. But this requires changing underlying data, which is only available in JavaScript. We get to add that data to the DOM with the help of the web core, which is the DOM, and its implementation, and then WebIDL, that is the description, formalized description of the DOM API. I stands for interface in API. In this case, not user interface, which is a user interacting with the world of the digital space. In this case, it's the interface between JavaScript. I stands for interface between JavaScript, one runtime, and the C++ runtime in which the DOM is implemented. So we are able to access that with the help of the DOM API as laid out in the interface description language known as WebIDL. But those are like name details. It's quite nice to know that framework, but we can see it here. Users, though, can take action and affect code in JavaScript. I love that. Events and handlers let users run JavaScript. Again, don't lose sight of that. Like, that's user action. When I write, I am triggering JavaScript code to run, which can then get info from the user's action, like what do they write, or we'll see later on, where do they click, X, Y coordinates of it, were they holding down command as they were typing? Those are pieces of information we can get about the user's action. And then make changes to the underlying data. That's what we did. And then we display that new data so the user sees the consequence. From HTML to JavaScript, though, from descriptive to imperative, from declarative to imperative. From me being able to say, I want, as intuitive as possible, I want to like put some text, and then I want an input field below it. So what do? I write text, and I write the next line, input. To, instead, that's called declarative or descriptive. Declarative UI would be saying what I want, by the way, implicitly also from just where I write it. Kind of beautiful. Because if you're thinking about so declarative, if you're thinking about like where I want to, what my output is, you want your code to look as much as like your output as possible, right? You know, a function like reduce, supposedly kind of a declarative style of writing, says reduce this data in this way. It sort of looks like its output. It's sort of got the output in the instructions. What's the output of writing UI code? It's where it's positioned on the page and what the content is. So you want your code, so declarative UI is the output is kind of in the code. It's like input below text, output is, sorry, it's very bad use, button below text, sorry, it's very ambiguous to say input below text. Button below text, the output is a button below some text. That would be a very declarative style of writing, versus imperative, which is describing how to attach it, which is not visually representative of what shows up. So with HTML, we could therefore state, describe our displayed content in intuitive ordered code. But without data, it was not interactive. Adding data, added interactivity, but also significant complexity. The rest of UI hard parts, and honestly much of UI engineering, really most of UI engineering, we haven't mentioned yet. Front-end engineering is a slightly broader camp. It's the actually also getting this data from the internet, primarily. But beyond that, much of front-end engineering is displaying vast amount of content and handling the user's interaction with it. That's your user interface. The rest of UI hard parts and much of UI engineering is aiming to reduce the complexity that comes with adding data. Gave us interactivity, but also vastly more complexity. All right, so we now move on, and we'll take a little break to do a wipe down, to one-way data binding. Popular paradigm for tackling that essential UI engineering challenge. Displaying content on the screen, letting the user change it, which implies underlying data changing, but also what they see changing. And with 1,000 pieces of content, all with associated data and display and view, and the user can change any bit of the view at any time with a handler function, and there could be 40 of them per piece of content, you get an exponential amount of complexity. Invaluable at scale, state and view with 1,000 points of interaction, and this is implemented. This has become the, if there's any, as I'm saying, like truths and moves, it's not catchy, whatever, fine. If there's any moves that have become almost like a default, it's this one. It's the idea of having the easiest way to handle vast amount of data and view, underlying data and that being displayed, where it can all change in different directions, and you've got to flow it through in the web browser. The restriction of that to, I can change only data when a user takes action, and then I'm going to run a pipeline that's going to convert that data to what's seen, and the user takes a new action. All it can do, it cannot affect what the user sees directly. All it can do is change underlying data, that's it, and then run that data to view pipeline. That has become something of an emerging standard. And while you can certainly, it is not a truth. But it is implemented in React, Angular, Vue, all of these libraries at least either default to implementing it, or it is a major aspect of their implementation. It enables us to build scalable apps with or without frameworks, because sometimes we want to, I mean, obviously it's one of those things that does sound kind of cool in interviews, whatever, when you say, I like to spin up my own virtual DOM, and that's what you're going to be able to say soon. But, or I like to implement my own one-way data binding implementation. A certain person does that for the front-end master's website. It does actually sound very cool. It's also totally legit. There are plenty of times where you really would, building an application in your team, build a vanilla implementation, a vanilla JavaScript implementation of the things that the Reacts, the Sveltes, the Vues, the Angulars give you, and or if you do use them, knowing how they're working under the hood should be hopefully pretty invaluable, allowing us to debug them and then answer the toughest interview questions. Okay, we are now going to do a wipe down before we jump into, I didn't change my headline there, before we jump into making our UI a little bit more sophisticated. We're going to let the user, we're going to have some default text in our field that says, what's up? When they click to start typing, it's going to clear that, and it's going to display both in the preview field below in the div and in the text, in text input, the text they're writing. Not that much more profound, but it's going to already start to introduce two handlers, a click handler function and an input handler, function to handle input. I don't want to use the word handler like without thinking, but it's just one of the few actually intuitive terms out there. A function that handles the input, a function that handles the click, and we're going to have some of that data flowing back and forwards. It's not going to be impossible to reason about, but very quickly we're going to wish we did not have 3, 4, 5, 6 different places we're affecting what the user sees. Because that's one of our biggest problems in UI, is when the user says, this thing showed up, and we're like, well, there's 500 places in my code that could have caused that. If we can restrict that to just be one place, one function, based on underlying data that we can track its change and determine from that what's going to be displayed through one pipeline, one function, we will be restricting ourselves, and it can be a total reshift in thinking to data must be behind every single thing that's displayed, but it hopefully should be quite empowering to us. Okay, let's take a 5-minute break to do a wipe down. All right.